Welcome to the video on the analysis and design of tall buildings by using ETAP software, in which we are going to design a 23-story building which has different sets of stories and their loadings are also different. Here all the stories have same dead load as 2 kN per meter square, but different live loads, that is from story 1 to 8 live load is 5 kN per meter square. From story 15 to 19 it is 4 kN per meter square. Then story 9 to 14 it is 4.5 kN per meter square, and for story 20 to 23 it is 3.5 kN per meter square. Also, three sections of beams and columns are going to design here, are listed here. So we are going to use M40 concrete for beams and columns, HYSD 500 steel and 250 mild rebar. The slab throughout the building we are going to provide a 150 mm thick slab having M40 grade concrete. Here we will use auto draw cladding whose load will be taken as 0.2 kN per meter. For the wind load we will consider the parameters for a building to be constructed in Bangalore city. Now open the ETAP software. Go to the file menu and select new model. Select usual options here, that is metric, Indian, IS 800 and 456. Then click OK. In the uniform grid spacing, the spacing can be used as 4 in both x and y direction, and the spacing of grids in xy directions can be taken as 6 meter in both x and y direction. In simple story data, the number of stories to 23 can be taken, and both for typical and bottom story height it can be 3 meter. Now you need to define the set of similar stories. So select custom story data and click on edit story data. You can see that story 23 is set as master story and all the other stories are set as similar to story 23. So this means all the stories are similar now, and you will create different master stories to divide the stories into sets of similar stories. Here story 1 to 8 are similar, so go to any one of these stories. Story 1 to 8 are similar, so go to any one of these stories. Let's say story 8 and make this as master story and select yes here. Then select other stories as similar stories to story 8. Now for the next set of similar stories, that is story 9 to 14, select story 14. Select story 14 as a master story and set story 9 to 13 similar to story 14. Again, set story 19 as master story and set stories 15 to 18 similar to story 19. And the remaining from 20 to 23 story are already similar to story 23. So click OK, select grid only and click OK. The 3D grid has been created here to draw elements on it. So go to define and select material properties. Go to the add new materials. Select a region as India. Material type as concrete. Standard as Indian and grade as M40. Click OK. Then click on OK again. Again click to add new materials and this time material type will be rebar, then grade HYSD 500. OK. OK again. Similarly add one more rebar material, grade mild 250. Mild 250. OK. OK again. Here three materials are defined. So click OK again. Now go to the define menu, select frame section from the section properties. Click on add new property and select concrete rectangular option. Enter a name for a column section as C 500 by 500. Select material type as M40. Then depth and width as 500 and 500. respectively. For the reinforcement properties, select Modify Show Rebar, set the design type as a column and change the longitudinal bar to HYSD 500 and tie bar as a mild 250. Keep other properties as it is. Click OK. Click OK again. Here one column is defined, so we need to define two more columns which are having similar properties, with the only difference is section dimensions. So instead of adding these properties each time, click on just define column and select add copy property. Add copy of property. Here change the section name as column 550 by 550. Change the dimensions as 550 by 550. Now need to go to Modify Show Rebar. Click OK. Again go to the add new, add a copy of property. Here name column 600 by 600. Change depth and width as 600 each. Add OK. Now you need to define fourth property, that is auto select. Click on add new property. Here under the special option, click on auto select option. Give a property name for the auto select list as column auto select column auto select, and then change the design type of change to the concrete. Okay, and then select the three defined columns sections and click on add button. So select these three and click on add button, then click on OK. So this now while drawing the column, we will not need to select individual sections, but the auto select property, the software will automatically select the best section from the list depending on the internal forces. Similarly, add the three beam sections properties. So click on add a new property. Select the concrete rectangular, enter the name of the beam section of beam 500 by 300, change the material to M40 and depth and width of the section to 500 mm by 300 mm respectively. For the reinforcement properties, select Modify Show Rebar, change the design type to beam, then change the longitudinal beam as HYSD 500 and tie bars as a mild 250. Set the top and bottom cover as 25 mm. And then click on OK. Click on OK again. Now we have to add two more sections with the same properties except the dimensions. So click on just defined beam property and select add copy of property. Change the property name to the beam 550 by 350 section and set the depth and width as 550 by 350 respectively. Click on OK. Similarly, select the beam one more time and select the add copy of property option to add another 600 by 400 beam. B 600 by 400 beam. Change the section dimensions as 600 by 400. Click OK. Now we will have to add auto select list property. So click on add new property and select the auto select list. Give the property name to the beam as beam auto select. Then change design type as concrete. Select 3 beams and click on add. Then click on OK. Click on OK again. To define the slab section, select slab section from the define menu. Select add new property. Enter the name as slab 150. Enter the name as slab 150. Change the slab material to M40 and change the slab thickness as 150. Click OK and click OK to exit. Now in the plan view, go to the story 1 by using the arrow key, or you may go from using set plan view option. So if you want to go by arrow key, click here. Here it is a story 1. Now select quick draw column from the draw menu. Or alternatively, you can use quick draw column icon from the this showing bar. Now change the property to column auto select, column auto select. Before drawing the elements, select similar stories option from the bottom right corner. Then select the whole grid area to draw the columns. Now select the quick draw beam option. You can see here from this icon you can use quick draw beam option. Then change the property to the beam auto select, and select the whole grid lines. Again select the quick draw slab option from here. Change the property to the slab 150 and select whole area. Now go to the any story from story 9 to 13. Let's go to story 10. Story 10. Again select quick draw column. Make sure column auto select is selected, similar stories is also selected, and then draw the required area. Again select quick draw beam option, select the grids in the required area. Then go to the select quick slab option and again select the required area. Again go to the any story between 15 to 19. Let's say on story 15. Go to quick draw column, select desired area, quick draw beams, again select desired area, then quick draw slab, select desired area, Now go to the any story from story 20 to 23. And repeat the procedure for column, beam and slab on desired area. Okay, so this is done for modeling. Now we are going to apply loads. So for adding dead load, make sure all storage option is selected. Go to select, go to first story, select story 1, then select all the slabs or shells. Select all the cells one by one. It is taking some time to select all the storage shells. Now go to the assign. Now go to the assign. Shell loads uniform. Here dead load will be selected. Type load as 2 kN per meter square and click apply. Click OK. Now we will going to assign live load. So for that you need to select similar storage option and select all the slabs or shells from story 1, then assign shell loads uniform, make it as live. Here live load is 5 kN per meter square. Apply. OK. Again we will assign the cladding load, which will be taken as 0.2 kN per meter on the exterior beams. So select first all the exterior beams and then assign the cladding load. Select all the exterior beams. Make sure similar storage option is selected. Though the cladding load is same throughout the building, but the exterior beams are different for different storage. So go to the assign, then frame load, distributed, here type 0.2, apply. OK. Now go to the 9th story or 10th story. Again apply all these three kinds of loads on these stories. So for that make sure that all storage option is similar storage option is selected. If it is not shown, go to the display and undo font shape. These two slabs should not be here, so we can delete them. Okay, so select all the slabs or shells from story 9 to 14. Go to the assign shell load uniform. Here live load will be 4.5. Okay. Again select all the exterior beams. Go to the assign frame load distributed. Okay. Now go to the 15th or 16th story. Make sure similar storage option is selected. So these two slabs should not be here. So select them and delete them. Again these two slabs are also not necessary, so select them and delete them. Now select all the cells or slab, go to the assign shell load uniform. Now it will be 4. Okay. Again select exterior beams. Assign frame load distributed 0.2. Okay. And now to the last story or story 21. You can choose any from story 20 to 23. So these are the unnecessary slab, so select them and delete them. Select the desired slab where we are going to apply load. Assign cell load uniform. It will be 3.5. OK. Select exterior beams. Assign frame load distributed. OK. But here at the top or the roof there is no cladding, so we need to delete that load from the top story. So select story 23. Make sure the story, only one story option is selected at the right corner. If it is not shown, go to display and deform shape. So select one story option only. Select exterior beams. You can see here only one story, that is top story or roof is selected. Go to the assign frame load distributed. Now change the replace existing load to delete existing load. OK. Now go to the base. Make sure again one story option is selected. Select all the slabs which are not necessary here and delete them. Okay, so select grid, all the grid, then go to the assign joints and then restraints. Select fixed one. OK. Now go to the draw. Draw auto draw cladding. Click to this. Select use floors option. OK. You can see here cladding is drawn. Now we will define wind load. So go to the define load patterns. So here type wind, select wind here, then select IS 1875, (1987). Add new load. Then go to the modify. So for this you can use IS code, and from map wind speed in the Bangalore city is 33. So from terrain category, from IS code 5 you can use clause 5.3.2.1, it is 3. Again using IS code you may observe that structure class is C, the risk coefficient and topography coefficients are 1 1. Click on OK. Keep other parameter as it is. Keep on OK again. Go to the elevation. Click on A, that is A side of the building. Click OK. Make sure all story option is selected because we are applying the wind load on the all stories. Select the cladding, go to the IS table 4, the H by W ratio will be getting as 3.83. so subcategory L by W is 1. So take coefficient of ABCD from the IS code and assign this coefficient to these frames. So go to the assign shell load wind pressure coefficients. Here assign first 0.8 windward direction. OK. Then go to the elevation, select B, OK. Select all the cells, then apply shell loads wind pressure coefficients, again 0.8. OK. Okay, then go to the elevation, select C, OK. The coefficient to the C and D side are same, so select D again and select the cladding from D side also. Assign shell loads wind pressure coefficients Here it will be minus 0.25 and it is levered. Okay. Then go to the elevation, select 1, okay. Select all the cells, then again go to the elevation, select 2, because all these faces have same coefficient as minus zero point 0.8, that is levered 0.8. So select all of them first and then assign. These coefficients are obtained from IS table 4, 875. That is last one is 4, side 4. Select all of them. Now go to the assign, shell loads, wind pressure coefficients, minus 0.8 leeward side, okay. Now go to the plan, story 1, okay. Here the wind loads are applied properly. There is 0.8 from this side, 0.8 from this side, 0.25 from this side and 0.8 from this side. Okay, so you can check at other place also, that is at story 11. Okay, again you can check it on story say 16. Or last story say 22. Okay, now select 3D view, go to the extrude view toggle, this is the extruded view of the building. Now you can run the analysis. So for that, go to the analysis, run analysis. You can save your file. Tall building design. Analysis process is going on. You can see here. can check here also. Wait for some time. So you can check the displacements values by keeping arrow on any member. Because this completes the analysis of the frame. Now we will go to the design part. So go to the design, concrete frame design, start design, check. You can see here the design process is there, or you can see here also. So it shows that analysis and design section differs for 705 concrete frames. Do you want to reiterate analysis and design? So auto select column or auto select beam option will used here. If you click on yes, as 705 members are not satisfied with the lowest dimension of the column or beam, so it will reiterate and takes the higher dimension of the beam or column and again analyze and design the building. Again it shows some of the members, that is 10 concrete frames, are again differing, so click again yes. As it is showing this message again, you can increase the dimensions of the beam and column, so click no, again no, now unlock the model. As you can go to the lock and unlock icon and click here, you will get, or you will unlock the model. So for this, click on lock unlock model. OK, go to the define section properties, frame sections. Here increase the dimension of beam, modify or show property. The higher dimension are 600 to 400, so go for 650 to 450. $652 $450. OK, then increase column dimensions also. Go to modify show property, column 650 by 650, click OK. Again click OK. Then go to the analyze, run analyze. This is done for the analysis. Then go for design. It again shows that the 703 members differ from section. Click yes. analysis and design section for one concrete frame. Again, yes. This time no message has appeared. That means all the members have designed properly. You can check it also by going to design, concrete frame design, verify all members passed. All concrete frames passed the design check. That means all the members are passed, hence design is complete. Now you can check displacement if you put the cursor on any member, or you can check the by right clicking on the beam member or column member. You can check the steel quantities, shear steel, bottom steel, top steel, its location, and the design code taken by the software itself. You can check the report also from this report tab, report summary report. This tab shows first tab shows model, which is we are viewing now. Second, display options. Third, tables, which shows load data, combinations, etc. And the last one, it will show a report. So it is generating a report. So in this case you can check whatever you want to check. This report contains all the parameters, data, properties and everything. In this way we have completed our assignment tall building design by using ETAP software. Thank you.